Hey everyone, today we're going to be building a game of Zelda in pure JavaScript, HTML and CSS, and no, we're not going to be using any fancy frameworks. No, we're not even going to be using Canva. This is pure JavaScript, okay, and this is to practice your fundamentals. Okay, so this is the final product. We're going to be building this game. You can see Link here. He can move around. He can, of course, kill the enemies and then move to other levels once he has killed them too. Now, these levels will loop because honestly, this is all about learning the fundamentals. I want to give you all the tools to essentially build this game, but then take it, make it your own, style up, add more levels. All of this will be possible by the end because this, once again, just to repeat, is a way for you to practice your JavaScript. Now, once you finish building this project, you'll probably want to show it off to the world. And to do that, you're going to need to deploy it onto the internet. I'm going to drop a link for Savala, which is a cloud platform that makes deployment super straightforward. All you need to do is connect your GitHub, GitLab, or Gitbucket account, and you're basically done. Push your code to the repository like this, and Savala handles the rest. So you simply select it from here, and it deploys to the internet. Easy. And here's the cool part, if you're deploying a static site like this one, it's completely free. Savala deploys it onto the Edge network so your site loads instantly no matter where your visitors are located. Whether you're just experimenting with projects like we're doing here, or you're planning something bigger down the line, maybe with a database, user authentication, the whole 9 yards, you'll be able to do it here too. So go ahead and click on the link in the video description to check out Savala and bookmark it for when you're ready to deploy. Otherwise, let's get to actually building this thing. Okay, so what are we waiting for? Let's do it. Let's build Zelda. Once you have finished your game, please do share it with me. I would love to see how you have taken this, taken your knowledge, and basically improved what you see here today. Okay, so here we go. Let's do it. I'm going to start off with my code editor, which in this case is WebStorm. Feel free to use whatever code editor you wish. I'm just going to go ahead and just start completely from scratch. So let's create a new project. And this is going to be an empty project. So let's just go ahead and do that. I am in my WebStorms directory that lives on my computer. And I'm just going to call this Zelda JS and click create. So that has just created an empty directory for me. There's no files or anything like that. And I'm just going to create a new file. This is going to be an HTML file. I'm going to call it index. You don't need to put the extension, but just in case you are in another code editor, I've done that for you. And some boilerplate code has been generated for me thanks to WebStorm. So along with that index.js file, I'm going to have a JavaScript file. I'm just going to call this app.js. And then one more file, it's going to be a style sheet. So once again, I just put style, or I could double click here and it will just add the style.css extension to let our code editor know to treat this as a CSS file. So a style sheet. So there we go. Those are going to be my 3 files. I now have to link them up. So they all live in the same directory on the same level. Like I said, it's going to be super simple. So we're not going to make it any more complicated than that. I'm going to call this Zelda in JavaScript, just like that. Now to link up our style sheet, well, we use the link tag. So let's go ahead and do that. It is a self-closing tag that actually doesn't need this, okay? It's one of few that doesn't. And then what I'm going to do is do rel style sheet. And now I'm going to link it with the href attribute. And it's just going to go to style CSS. Okay, so that one file there. Great. And the script tag, we're not going to actually link it up in here. I'm going to use the DOM content loaded method. I'm going to explain that in a bit. So we are done with this setup. At the moment, we will come back to it when the time comes to execute the JavaScript. I'm just going to put some very basic things in the body. Okay, so not much. Like I said, this is going to be super simplified. I'm going to create a div. And here is essentially, let's give this the class name of UI, is going to be stuff such as the player current score, the playing current level, and the enemy counter. So these are just going to be simple p tags because like I said, we're making this super simple so that you can take it and essentially do with it what you want. Okay, so I'm going to span. So the score we'll put here, and then I'm going to break up that p tag with the span. I'm going to break it up because we want to pick out just this little bit here. Okay, so if I do ID score, we can just pick out this span element and not affect this score word right here. So that is it for the score. Then what did I say? I said we're going to have some levels. So level, which means this is the ID for picking out the level. Let's start with level 1. So I'm just hard coding that. Enemies. Let's have the enemy counter here. So enemies. Let's start off with 2. So I've hard coded that. We can change it with our JavaScript later on. Great. So we have this div here and one more div here. It's going to just be for our game. So I'm going to give this the class of grid, okay, because our game grid is going to go here. And final one is just going to be a p element that says use arrow keys to move, space to attack. So that's our game instructions. And honestly, that's really it. I feel like we've done everything. So now if I want to see this in the browser, I copy the path, copy the absolute path, and just paste it in like so. So that is what my screen looks like at the moment. Okay, if I inspect it, you will see that's literally what we have in the body, the div with the class UI, the div with the class of grid. So we're going to be injecting a lot of elements into this div, okay? At the moment, it's just a div that is empty. It's going to have so much stuff in there that we're going to inject into it with JavaScript. And of course, this P element right here. Use arrow keys to move, space to attack. Great. So let's continue. I think next we should maybe style this up a tiny bit. So let's go to our style sheet. So let's get up our styles. Okay, so what I'm going to do is just grab the whole body like so. And again, it's going to be super simplified. Let's do font family for any fonts that we use. I'm going to use Courier New and then monospace as a backup. So it's kind of retro fonts that I am using. The background color, I'm going to go with #1. So we're using hex values for this. 1A, 1A, 2E. I have picked this out already. It's a dark blue background. The color of the text is going to be white. So that is a shorthand for writing 6 Fs. It's still white. And now I'm going to use display flex. So this is initializing flexbox so that I can use flex direction column to make sure everything in the body stacks up on top of each other from top to bottom. And then I'm going to line items center. This is going to center them horizontally, and I'm going to use justify content center 2 to center them vertically. But this will not work unless we have a height. So I'm going to put min height 100 viewport height, so the height of the browser essentially. Okay. So at the moment it will just look like this. Okay, so we've added a few things. Let's also, here's the body, here's the grid, here's the UI. I think for the UI, let's do the grid first actually. So I'm just going to go back to here. Let's pick out the grid just like so. And I'm going to say that the grid is going to have a height of 432 pixels. Again, I've already picked this out. A width of 480 pixels. We're going to have each of the grid, because it's a grid-based game, right, made of lots of little squares, and every single square is going to be 48 by 48 centimeters. So this means that the width is actually 10 squares, and same for here, that's going to be 9 squares. So that is the height and width. For now, maybe let's just give it a box shadow so you can see what's going to look like. So 0 and the x-axis, 2 pixels on the y-axis, 4 pixels spread, and then the color, well, I'm going to use RGB8 because I want to make it transparent, so 0, 0, 0.5 opacity, and then inset, and then I'm going to have another one on top, 0 x-axis, 1 pixels y-axis, 0 blur, and make it solid white in color. So now if you have a look, there's the grid. I'm just going to zoom back out. Okay, that's what we've created. So it kind of has this 3D effect. So again, UI, grid, P element. I think the UI, I don't want this to be stacked on top of each other. I want it to be the full length. So what I'm going to do is go back here and let's grab the UI just like that. And I'm going to use Flexbox to do this again. So display flex. So this essentially initializes Flexbox, and I'm going to use justify content space between. I'm going to show you what this looks like. We also actually need to say that the width of the whole UI is the same as the grid, so I'm just going to copy that there. Great. So now you will see that the UI, there we go, is 480 pixels in width, same as this, but the space in between is equal. Okay, that's equal, and that's equal, and that's thanks to space between. So display flex made each of the texts, so this text appear on a straight line essentially, and then space between spaced that out. If you don't believe me, check it out. So that was what it looked like without the justify content, and without display flex, that wouldn't even work. Okay, cool. Let's move on. So great. Do you know why I am here? Okay, that is our grid, of course. However, we're going to also say, because we already know that every div that we put inside that grid, we're going to put in divs with JavaScript. I already told you it's going to have a height of 48 pixels and a width of 48 pixels. Okay, so we don't have any in there at the moment, but I'm just going to leave it like that for now. Wonderful. So now let's get to creating our board. I think that's the first function that we'll do. So like I said, I'm going to use document and add event listener. So hopefully you've used this method from JavaScript before, listener. And then we're going to listen out for DOM content loaded. Okay, so this is going to wait for the HTML document to be fully loaded before executing the game code. And once it is fully loaded, okay, meaning that all of this has been loaded, so you can put a script tag here. It's kind of the same, but this is a little bit more foolproof because we're saying, oh, wait till everything is loaded, and then it's going to call this function, which is essentially the game code. Okay. So now what we're going to do, like I said, I want to inject elements into the grid. So const grid, what we're going to do is use document again, and we're going to use query selector to look for any element with the class, is it class name? Class name of grid. You could use class, we should probably use ID. So let's look for anything with the ID of grid, because we know that the hash means what we're looking for an ID. Great. Okay, so that also means that we need to change that here. So there we go. We're looking for an element with the ID of grid, an element for an ID of grid, and any div that lives inside of it. Wonderful. Okay, so you can use query selector, or you can just use get element by ID, it's up to you, but then we don't need to specify it's an ID because, you know, that kind of is already doing it for us in there. So we're grabbing the grid, that is cool. While we're here, I'm also going to grab the spans. So this whole element I can grab by this ID. So let's go ahead and do that. I'm going to do score display, look for element with the ID of score. Let's do the same for the others. So we also have the level display and the enemy display. So look for level, look for enemies. Great. Okay. So we've already discussed this. The width of my game grid is 10 squares, which are all 48 pixels wide. In fact, I'm just going to define the tile size here as well, 48. So this is each tile size in pixels, which is 48 by 48 pixels. And now what I'm going to do is actually, well, we are going to create the board. So let's write the function create board just like that. And what we're going to do is loop essentially. So let's write a for loop for let I equals 0. And as long as I is smaller than 9, we're going to increment I by 1, okay? So we're actually going to loop through each row first. So imagine the grid-based game is a row. In fact, maybe it's best to kind of get the layout first of these games so you can fiction them better. So let's define maps. So let's have 2, right? Because we have 2 levels, it's going to be an array. And my first maps is going to be an array that lives inside of an array. This is essentially our first map. If you want, we can even annotate it, level 1 layout. And I'm going to do it for you in a way, because usually you just write in a string. I'm going to do it visually for you. So let's write the string of the top row. So essentially, what I'm going to do is say that certain things are described, corner walls and so on. So I've already written this out for us. So these are going to be corner walls, meaning that the visuals that you see or saw on the Zelda have already been planned out. I did this in advance to save you time. A and B are going to be side walls. C and D are going to be top and bottom walls. This shape right here, so this is going to be lanterns. This is going to be fire pots, so this shape right here. This is going to be a left door. This is going to be a top door. This is going to be stairs. This is going to be the slicer enemy. This is going to be a Skeletor. And then a space is just going to be an empty walkable area. So using this, I'm going to create my map. So let's go with Y. So this is a side corner wall. Then CC, as we know, this is a top and bottom wall. Then I'm going to put a lantern. So I'm going to go like that. CC again for a wall. Then there's going to be a door. So that is a top door. CC for walls and W for a corner wall. Okay? So that is my first top row with the top door in the center. Now I'm going to do the second one, so second row, and that's going to be A because that's a side wall. And I'm just going to have a bunch of spaces here, okay, and a B. So that's the other side wall. So great, that's side walls with an open space. And we said that this was going to be 9 squares high, so we need 9 of this. So we already have 1 row, 2 rows, 3 rows, but let's have a slicer here, I think. So let's just put the slicer there. Let's put a comma there too. Then we have another one, and this time we're going to put a lantern here. So let's put the lantern there maybe. Really is up to you where you want to put this stuff. Let's have another one, but instead of a wall here, I'm going to put a left door. I'm going to grab this once more. Let's put another lantern. And then let's put another slicer. But this time I want the slicer to be here. Okay? And then finally the bottom row, which is going to be, again, corner wall, bottom wall, lantern, bottom wall, lantern, bottom wall, corner wall. Okay, so imagine this is my layout, okay? If you put it all on one line, it wouldn't look so nice and might be quite visually difficult to really see what's going on. You'd be like, what is this? At least this kind of resembles the map we are doing. So this is just for us. The computer won't know any different. This is just for me and you, so we can kind of see what our map looks like. Okay? So now what I'm going to do is actually I'm just going to put in a second layout, which I've already done as well. So let's make another array. This is going to be level 2 layout. So level 2 layout. And using the same key, I've just created a second layout. So now you can actually add as many layouts as you want using the key here, okay? You can keep that if you wish, it's up to you. So once again, these are our two levels. Let's continue. So now I'm going to use those two arrays essentially, and I'm going to loop through each row, right? Because like I said, this is a row and there's 9 rows. Hence we are looping 9 times. So that's going to loop through each row. Then I'm going to loop through, so this is inside that, for let j equals 0. As long as j is smaller than 10 this time, because there's 10 columns, j increments by 1. And for each time it does this, it's going to create a square. So const square, and we're going to use square equals document create element. So we're going to create a div, but there's just kind of currently just a div, right? It's not even in our grid. We just assign it to the const square. That square we're then going to grab and use set attributes, so another JavaScript method, to assign an ID to it. And that ID is just going to be the loop that we are doing. This unique ID is actually going to be based on the position. So I'm going to get I, multiply it by the width, which we know is 10, plus the value of j. So before we start adding the characters to these squares, I just want to show you what that looks like. I'm going to grab the grid, which we already picked out in the first few rows. I'm going to use another JavaScript method called append child to put in the square we just created. Okay, so now if I call this function, I'm just going to do so down here. And now we need to add the script tag to our HTML document. So instead of putting the script tag here, we're actually going to put it in the head. So I'm going to put script up here, just like that. Source app.js. So now our DOM content event listener will listen out to when all the HTML elements have loaded and then execute the JavaScript in a foolproof way. Let's check it out. Ta-da! So now, like I said, we've injected all these divs. Okay, we've given them ID 0, 1, 2, 3. They're going all the way down, however. So we don't want that. See, do. We actually want them to wrap from left to right and then make another one and another one, another one. So we do that with CSS. So back on the grid, I'm going to use display, flex once more, flex, wrap. Okay. So there we go. So now it goes diag, this exactly like I wanted on the next row, and so on. And you will see these IDs have been assigned to the divs like I did here using JavaScript, using the set attribute. Okay, so if this was 0, 0 multiplied by width is still 0, plus j, which at the moment is 0, that's 0. Then, of course, we're still in the columns, right? And we have to complete all the columns until we move on to I. So it would be 0 multiplied by width is 0 plus 1, which would be 1. 0 multiplied by 0 is still 0 plus 2, and so on, until we get all the way up to 9. And then this turns to a 1. So 1 multiplied by width is 10 plus j, which is 0, which gives us a 10, and so on, and so on, and so on. So hopefully that explains it. Let's move on. Okay, so we've done that. The next thing we'll do is get the character at this position in the map. And for that, well, we're going to have to essentially get the levels. So get the maps here. And inside this function, I'm going to get the current map. And the current map is simply the maps. And I'm going to open my array, and we just want the first one, right? So let's also maybe assign some variables here. So I think what we should do is let's also collect the squares all in one array as well, so we know what we're working with in the JavaScript file, not just when we look at the game grid. Let's score, start with 0, let level We do want to start at level 1, yes, but in computing we start counting from 0, so it's going to be index based. Let player position. Well, now that we have assigned IDs to all our divs, I know that I want it to go in the div with ID or index 40, so I'm going to put it there. Let enemies, we're going to collect our enemies in an array again, just so we can keep track of them. And we'll start off with the player direction being right. Okay, and of course, let game running. We'll start off with it being true. So when you kind of, just go open the browser, it's already running. Cool. So now let's use this level variable and put it through into maps, because this will get us back the first map. 0 is essentially 1, it will get us back the first map in our array. So that is the current map that we are working with. So now if I get the current map and I go into it, right, because this is the current map, and I go into here, that is the first item, and I want to go further into it, I do so again, just with another array. So that is how I get the exact character that we want to get at its position in the map. Okay, so maybe let's just save this as char, so character, and we're going to write another function for this add map element. This is going to process this character to add appropriate styling to it and so on. So that is something that we are yet to write. So we'll pass through the square that we are working with, we'll pass through the character, and of course we'll pass I and J as the positioning references. So I'll comment that out for now. So at the moment, yes, we are putting the square in the grid, but like I said, we also want to save it to this file, which is why I made a squares array. So I'm going to do squares push, and I'm just going to push in that square. Okay, so amazing. If I console log squares after this whole function has run, just comment this out like so. Ta-da! We get all our divs. This is great. Okay, so I'm just going to maybe do that, and let's work on our add map element function next. So I'm just going to do so here. So function add map element, like I said, we pass through the square, the character, then X and Y. We did pass through an I and a J, but essentially it's the same thing. And this is essentially just going to be one long switch statement. So we'll pass through the character like so. And if the character is an A, well, we know this is a left wall, right? Because we have our key to refer back to. And in that case, we use square class list. And we add the class we are yet to write called left wall, okay? And then we simply break out of this. So that's all we're going to do. We're going to do this a lot. So left wall, essentially, let's just go down here. Just going to zoom out a little bit for you. And left wall, so dot left wall, well, it's just going to be an image. So background image. Now, I've done two things in my code that I've attached. I've actually added all the images. However, if you don't want to get all the images, that's fine. I've also stored them on Imager. So here you go. This is essentially a picture of a left wall. So you're more than welcome to take this link. So you could do that. Or what we can do, and I'm just going to do that here in case whatever image goes down or something, I'm not sure. I'm just going to make an images folder, and I've already got all the images. I've downloaded them already because, you know, they are mine. This took me a long time to do, and I'm just going to whack them in like so. So here they all are. Okay, so now you can see them. There's link, there's some walls. It's really all of them. There's so many. Please feel to check out my code. Okay, so let's go back. So like I said, you could do this, or you could just go to images, just like that. Okay, so left wall we have done. So now, well, actually we can go ahead and just comment these out. And ta-da, you will see those left walls are being applied. Great. Let's move on. Okay, so perhaps I'll just make this a little bit smaller for you. And let's carry on. So this will take a while. We also have case B, so I don't know how you want to do it, but we could just copy that. And this is going to be right wall and then break, and then we have case C, which is going to be a top wall. Then we have case D, which is going to be a bottom wall. Let's move on. Now we're going to do W, which is going to be a top right wall, top right wall. Then we have X, which is going to be a bottom left wall. Then we have Y, which is going to be a top left wall. And then just the bottom right wall, which is going to be a Z, so bottom right wall. Okay, cool. Now let's do the left door. So left door, this is going to be this, if you remember from our key. And then the top door was this little hat. So that is top door. What else do we have? So maybe it's better just to do that for copying. So then we have stairs, which was a $sign, and this was stairs. Then we have this, which was lanterns, lanterns. Then we have the other side, and this was fire pot, fire pot. Then we have this, which is slicers. So for this, I'm not going to do that. I'm going to actually call a function called slicer, which we're yet to write, and pass through the column and row positions. And then the same for this one. This is going to be for Skeletor. So let's write a function called create Skeletor. And once again, pass through X and Y. Great. Okay, so now we need to add that here. So we have the left wall. Let's do top wall. And once again, it's going to be background image URL. It's going to do this a few times. So once again, I think it's best to copy this. We have top wall. We have bottom wall. We have right wall. We have bottom left wall. We have bottom right wall. We have top left wall. We have top right wall. Then let's move up to the doors. So top door, left door, stairs, fire, pot, lanterns. There you go. Slicer is going to be coming up. So once again, that's an image and Skeletor. We're going to have another one which we haven't seen, and it's kaboom for the little explosion as well. So now I'm just going to go ahead and add those images. So once again, they live in images, and this is going to be, just maybe just put that in all of these. It's a shame we didn't include that in our copy paste. Images, 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 images. They all live in the images directory. Okay, so like one big happy family for now. Okay, so left wall we did. Let's do top wall, bottom wall. So apologies, this is a bit repetitive, but it's necessary. It's a necessary evil. We'll know very quickly if we got anything wrong as soon as I refresh the page, because we've already done all the mapping of the characters onto the map. So at least that's a positive, right? We're not going to carry on coding and then be like, oh no, we've used the wrong image. It'll be super obvious to us as soon as we finish adding all of these. So top right wall, and then we have the top door. So let's paste that in like so. Then we have the left door. Then we have the stairs. Then we have the fire pot. Then we have the lanterns. Then we have the slicer. And then we have the Skeletor. And then we have the kaboom explosion. So now, ta-da! This is looking good. And of course we see something went wrong here, so let's figure her out. But like I told you, super simple to find out. We found that out pretty easily. I do also have a background, and we do also need to add our little link character. So let's look at the top right wall first. So top right wall, what is up with that? Aha, it's because we put a dot. Okay, so maybe the eagle-eyed of you would have noticed that. But there we go. So that is looking good. Okay, let's also add our link positions. Even though we haven't actually added link, he will be there. So we'll do link going left, and this time I will copy paste everything like so. So link going left, then link going right. Then we also have link going down and link going up. Okay, and once again, I already have these in my images folder. So there's 1, there's 2, there's 3, and there's 4. And finally, on the grid itself, I'm going to do background, URL, images, and once again, I have an image in here for the background, so I'm just going to do that. And I want to make it cover. So background, I want to make it cover the whole thing, background size, cover. Okay, so now it looks like this. How cool is that? So great. I think we also need to give the grid a position of relative, as we're going to be putting stuff in there. So let's add position relative, because we're going to position everything that goes inside the grid, and we need to do it based on the grid, not the actual browser itself. Okay, so I'm happy with this. I'm just also going to get rid of any padding, so padding 0. Let's make sure that on the divs themselves, we also make the images cover them completely. So using background size cover, no repeat center, just in case. And it seems that we missed a row, so 1, 2, 3, 4, 5, 6, 7, 8. Let's go ahead and add another row. So again, it's so easy to see if you made a mistake. Let's go back all the way to the levels here. And level 1 here, I'm just going to make sure that this is indeed 9. And once again here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's change the level to see what the second one looks like. So I've just changed that to a 1. And this is what our second level looks like. Okay, that is good. Let's go back. Great. I'm happy with this. So now let's move on. I'm just going to go back to our create board function for now. And after we've essentially mapped through all of this, but still inside the function, I want to create player. Okay, so let's write our create player function. So all the way down here, I'm going to write a function, just going to move this up, function create player, just like so. Now, the main character Link, we're going to essentially put him somewhere on the grid. So let's go ahead and do that. Document create element, just like so, and create a div, const player element. And now I'm going to grab that player element and use class name to give it the class name of link going right, which we already wrote before. I'm also going to give it a ID so we can pick it out on the board. Element ID equals player. So now once again, the grid which we picked out at the very beginning, if we use append child and append the actual player to the grid, or player element that is, ta-da, Link at the moment is here. So if we look in the grid, there he is. We also need to position him. So before we put him in, we need to position him. And what I'm going to do is essentially calculate and set the horizontal position. So we're going to get the player element style left. And using backticks, I'm going to get the player position, which we know is 40. We set it above. Modulus width multiplied by tile size, which is 48. Okay, so the player position modulus width converts linear position to column number. So imagine position is 47, and 47 modulus 10 leaves a remainder of 7, right? Because modulus finds the remainder, so the remainder would be 7, which means the player is in column 7 of the grid. Now, 7 by itself means nothing. We want to actually not move him to the left 7, move him to the left 7, multiply by 48, because that is the tile size. So that would appear that he is, let me show you. First off, however, we do have to set a position of absolute to Link. So maybe let's do it here. I'm going to do it for Link going left, Link going right, Link going down, and Link going up. So position absolute is needed, so he appears in the grid. Let's also set the width and height of Link. Like I said, everything is 48 pixels. So 48 pixels, 48 pixels. And then just to make sure he's always in the front, I'm going to set a Z index of 10. And once again, just in case, don't think it should make a difference, but you know, just in case your image is a different size, we just want to make sure that it fits in that 48 by 48 square. So now Link is there. Okay, and style left is 0 pixels at the moment because console log, just get all of this, 0 is being passed through into here. Okay, because 40 is our player position, modulus width leaves 0 remainder, and 0 multiplied the tile size is still 0. So this is 0 pixels left, which is exactly what is being passed through. Great. So now let's do the same for the top. So player style top. And this time, again, in backticks, what we're going to do is calculate and set vertical position. So we're going to do row multiplied by tile size. However, we're using math floor to essentially round down. So let's say the player's position is 47 this time. 47 divided by 10 with math floor is 4, meaning the player is in the 4th row of the grid. But again, we have to multiply by tile size, so he's in the right place. Great. So ta-da, he ends up here. So this is looking really good. We've created our player. I'm happy with this. Now let's do the same for enemies, right? So let's do it. I'm just going to clean this up like this for now. You can just do player class name, or you can do class list add and do that if you want. Both are going to give you the same results. Okay, so it's up to you. I'm going to do that just because I was doing it all above here. So let's create the slicer next. So function create slicer. So once again, I'm going to do const element this time. Document create element. And then we're going to create a div once more. But this div is nowhere at the moment. Okay, let's also do element, or maybe let's be more precise and call this slicer element just because we did so above. So let's get the slicer element and do class list add, and we're going to add slicer. So an image of a slicer will be applied, and a slicer element, once again, style left equals, and then let's do top as well. Okay, so just like that. And for the left, well, we're just going to use the X that we passed through, multiplied by the tile size. And for the Y, or the top, we're just going to use the column that we are looping over, multiplied by the tile size, to position vertically based on the Y coordinate. Okay, we are not yet done, however. First of all, we of course need to grab the grid and append child slicer element, just so we can actually see the slicer. So let's uncomment that out for now. So, ta-da, there they are. However, this has messed everything up for us. Okay, it's kind of pushed everything out. No, this is because we also, just like we did with link, I'm just going to go to the slicer. So here is our slicer. I'm going to grab the slicer and grab Skeletor. And once again, we need position absolute. Let's assign the width 48 pixels. Height 48 pixels. Z index, I'm going to go with 5 this time. And once more, just in case you're using different images or they look funky, I just want to make sure they cover the whole square. So now that looks much better. Okay, cool. So our slices are there. The next thing to do is actually make them move. So let's do that now. So before we put the slicer in the grid, I'm going to actually create a slicer object with properties. So this is going to be X, Y, and then direction. So let's start off with -1. Type, I'm going to go with slicer. So this is just an enemy identifier, really. And then the reference to the DOM element, okay, which is going to be the slicer element. Make sure to spell direction correctly. So it's the direction. Okay, so this is the current position. In fact, let's just put these on that line. That's the current positions, the X and Y. That's the movement direction. This would be a -1 or a 1, the identifier, and the DOM element itself, or the reference to the DOM element. Okay, so we are collecting enemies. So I'm going to just push that through, push the slicer in so we can keep track of them. And we know that's a slicer because in it will say type slicer. And you could probably even see the slicer element. Okay, so we're collecting all those enemies. That's good because we're going to want to know how many enemies we have killed. And now using the same approach pretty much, we're going to create Skeletor. So let's do it. I'm just going to move this all up here. Function create Skeletor. You of course pass through X and Y. So you know the drill, document, create element, div. Let's save this as Skeletor, class name, add Skeletor, Skeletor element, style, left equals this, and Skeletor element style top is that. This should actually say classless add, sorry. And now we can essentially uncomment out the create Skeletor function. Okay. So now let's also get the grid, use append child to push in the Skeletor element. We'll also get the enemies and push in the Skeletor object that we have to make. So const Skeletor equals, and then let's pass through the current positions, direction. Let's also start off with -1, timer. Okay, because we're going to have a random timer for direction change on this one. So let's do math random. Let's call it and multiply it by 5. Okay, so this will change every 0 to 5 seconds, right? Randomly, it will produce a number from 0 to 5. The type is going to be Skeletor, and I'm going to pass through the reference to the DOM object. Cool. So amazing. I think that looks good. Once again, if I just go all the way to the top and change the level, ta-da, there's our Skeletor. Amazing. So now let's actually make everything move. Let's just change that back to 0 and let's continue. Okay, so that is my full create Skeletor function. Let's work on the move player function next. And this is going to be quite a long one, so I hope you're ready. Okay, so after the create Skeletor function, I'm just going to move all this down. It's time to write our function called move player. And the move player, this is going to handle the player movement. So we're going to handle it by putting it through a direction. And once again, we're going to get reference to the player DOM element. So we're going to go document, get element by ID. And luckily, we gave Link an ID of player, so we can now pick him out wherever he is on the game board. So let's also assign this to player element, just like so. And we're going to get a new position as the current position. So let new position. And we're just going to get the player position, which we set to 40 at the top of the screen. So now we're going to handle the movement based on direction input. So whatever direction we put in, so whether it's left, right, you name it, we have a case for it. So if he's going left, we're going to use modulus again. So we're going to check if the player is not at left edge of grid. And we're going to do player position modulus width to give us the column number. So either it's 0, 1, 2, 0 to 9 will come back. And if the result is 0, it means the player is in the leftmost column and can't move left anymore. So we know where he is. He's in the leftmost column. So that's how we're going to use modulus to figure out where he is in which column. So if player position modulus width does not equal 0, so if he's going left, right, he can continue going left, because as long as he's not in the leftmost column, he can go left, which means we can change the new position. And it's simply going to be the player position -1. So he appears to be going left. Okay? So great. That's only if it is not 0, meaning he's not in the already most left-hand column. And let's now get the player element, class list add, link, going left. Okay, and then we'll change the player direction to also be left continuously and break out of this. Now let's do the same for right. So in fact, I'm just going to copy all of this, and if right, so this time we're going to check if player position modulus width does not equal width minus 1. So width is 10, minus 1 is 9. So we know, essentially, just like with the left, that if the column, if link is in a column that is divisible by 9 and leaves no remainder, he's in the rightmost column. But if it's not, then he can continue moving right. So we change the position. We change a new position simply by adding 1. Okay? And then we change it to link going right. And we change the player direction to right. So a good example of this is, imagine if the player position is 29. 29 modulus width does leave a remainder. It leaves a remainder of 9. So we know we're at the right edge, so this does not apply. We don't do anything. However, if position is 25, 25 modulus width, so modulus 10, leaves a remainder of 5. That does not equal 9. So yes, we can continue to move right. Please take this really slow if you don't understand, and console log so much of this so you can see the numbers changing, and hopefully you will get it. Okay, so once again, this time case up. And for this time we're going to get the player position. Once again, this time we're going to minus the width, and we're going to check it's higher than or equal to 0. So we're just checking if the player is not at the top edge. And if the player position is, for example, so what's the top edge? It will be anything 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So like say it's a 9. 9 minus width is minus 1. That's not higher than 0. So we would just get out of this. However, if player position is 15, 15 minus 10 is higher than 0. So then we can go up one more, which means we change position. New position, player position, and we minus a whole width from it. Okay, we minus a whole width, we minus a whole 10 squares. Okay, a whole 10 squares. So if we're here, for example, minus 10 squares, so will take us to here. Okay, so a whole width would just mean that we're here. Another whole width would mean we were here, and so on. That's why we're minusing the width. Okay, and once again, we update the player visually. So let's do link going up and player direction equals up. And you break out of this. The last one is down, so I'm just going to copy all of this down. And if player position, this time plus width, is smaller than width multiplied by 9, we change the position again, and this time we add a whole width, so we can go down. So we're just checking if he's not at the bottom edge first, okay? So the position has to be essentially smaller than 80. And if he's not, well, then we change the position to make him move down a whole level. So this time, player going down, and then player direction is down. Okay, so I think we should check this out. So in order to do this, we actually need to hook this up to listening out for keyboard inputs. So key down is what we're going to listen out for. So document add event listener, just like so. And we're going to listen out for any time we press a key down on our keyboard, and then E for event, because we're going to know which key we pressed. And then what do we do? Well, first, if the game is not running we don't do anything, right? Because if the game is not running, if it's a game over, we don't want to be able to move link on the board. So do that. And then let's use switch again. We're going to pass through the key code that we pressed. So we're doing a lot of switches in here. Case arrow left. So if you press the left arrow, we move player and we pass through the direction of left and we break out of this. So now I think you know what to do. Let's copy this. Let's have 4 arrow right, move player right arrow, was it up? Just trying to do it in the same order that we did it before, and down. Move player down. There is going to be one more case, and that is if we press the space bar, and then we're going to spawn a kaboom. So we are yet to write this function. It's just going to go kaboom, essentially when we attack an enemy. Okay, so let's check it out. Okay, so now if you move and you're not on here, there's actually a bunch of scrolling that happens here. We don't want that. So I'm also going to add prevent default to all of these because we don't want any scrolling happening. Okay. So now that shouldn't happen. Okay, cool. This is looking good. So he's moving up. That seems to be the only one that is happening. We just need to actually visually make him move as well, not just change the new position. This actually needs to be shown on the board. So I'm also going to get the player position now and change that to be the new position. And I'm going to get the player element style left back ticks. And just like we did before, position them on the board, player style top, back ticks. So now he should move. This is looking great. Of course, there are still fewer things we need to figure out. For example, all the classes are adding. This is not what we want to do. We want to completely replace the class. So that is good to know. Instead of class list add on these, I'm just going to do class name equals to completely override it and get rid of the other one. So class name equals is necessary for these. Okay, great. Okay, because you want to just replace it completely, not add it to a list. So there we go. So now he will appear to me moving in all these directions. This is looking great. I'm happy with that. Let's move on. Let's do collisions next. So I'm just going to go ahead and still in the move player function. So after we change the direction, but before we assign the new position, I'm going to check if can move to. So this is going to be another function that we write. And we're going to pass through the new position. So let's write our can move to function. So just going to comment that out from now. So let's do so down here. Function can move to. We'll pass through a position to check that position if the player can move to it. Okay, so if position is smaller than 0, or we're checking if the position is outside the grid boundaries, right? Or position is suddenly larger than or equal to squares length, because obviously if it's below 0 or longer than the amount of squares we have, then no, you need to return out of this. And we'll return just a false value. Okay, so can move false. Otherwise, so let's get all the squares, and I'm going to pass through into that squares array the position. because we need to find out exactly what square we are dealing with, okay? Exactly which one of these we are dealing with. And pick one out to check. I'm just going to save this to square as the square we are working with. And we're going to return true if the square doesn't contain any blocking elements. Okay, so it doesn't contain a wall, doesn't contain a lantern or anything like that. So we're going to return if the square class list contains left wall. So we're going to return it if it actually doesn't contain this. And if it doesn't contain, I'm going to put this on a new line, a right wall. And so once again, it's going to be a lot here. Doesn't contain a top wall and doesn't contain a bottom wall and doesn't contain a top left wall and doesn't contain a top right wall and doesn't contain a bottom left wall and doesn't contain a bottom right wall and doesn't contain lanterns and doesn't contain a fire pot. Okay, so those are all the things that we want to essentially check for. Okay, and that's it. That's really our can move to function. There we go. So now we can uncomment this out and work on it. Okay, so if we can move to the new position, so it's not valid, it's not blocked by wall or an obstacle. So if that is true, returns a true, then we're going to get the square the player is moving to. So once again, squares, we're going to look into them. However, we're going to pass through the new position this time. So the new position that we got, and that square is now what we're going to work with. So whatever the future position is. And if that square class list contains left door, then we know that it could be open. So we're checking for interactive doors that could be open first. So if that is true, we're just going to remove it. Class list remove left door. Okay, so that is one thing that we are checking. We can also check for level progression triggers such as stairs or a top door. So if square class list contains top door or square class list contains stairs, and if enemies, so all the enemies that exist, right, because we're collecting all the enemies of the level, if they suddenly go down to 0, so there's no enemies. So only if there's no enemies do we advance to the next level. So if we are about to interact with the top door or about to interact with stairs and there's no enemies left on our game board, then we can progress to the next level. Else, I'm just going to show a message. So show enemies remaining message and call it. So two functions that we need to write. And then we return. So we exit the function without moving the player. Okay, great. So I think this looks good. What do we want to work on next? I think let's work on next level. So I'm just going to comment that out. So once again, I think let's do this here. So function next level. This is actually going to be pretty easy. We'll just get the level, and then whatever the level is we're going to add 1 and then modulus maps length. And this is actually going to allow us to cycle through levels infinitely. Of course, when you have your own levels, you probably won't want to do this. You want to add your own. But for now, I'm just going to make them repeat over and over again. So that is a nice way to do this. Okay, and we're going to create board. So create the next board. So great. I think that looks good. We will test that out soon. We can't really test it out for now because we wrote a condition that we need to kill the enemies first. So let's maybe do that next. However, before we do that, I'm just going to also do the show enemies remaining message. So let's grab that. And once again, it's going to delete a few of these. Function show enemies remaining message. And what I'm going to do is just grab the whole grid itself. I'm going to use style filter and I'm going to apply a different hue essentially. So just a string, and this is going to be applied as the style filter. Okay, it's just going to create a dramatic effect of kind of like a brightness, and then I'm going to do grid style and add a box shadow. It's going to be 20 pixels blur red, 0 on the X and Y axis for the box shadow. And I'm going to remove it after a certain amount of time. So set timeout is the method that I'm going to use for this. And I'm simply just going to clear those again. So after a certain amount of time, this is going to go back to just nothing, essentially, an empty string. And that's going to happen after 300 milliseconds. Okay, so it's going to flash red, and then I'm actually going to write another function. It's going to be show temporary message, and I'm going to pass through. I'm yet to write this. Defeat all enemies first. I want the color to be, the text to be red, so I'm going to pass that through as a string, and I want it to last for 2000 milliseconds. So now I'm going to write this function. Okay, let's do so here. Function show temporary message, and then of course we do pass through a message, we do pass through a color, and we pass through a duration. So I'm going to use document, and I'm going to create an element. Once again, it's going to be a div. So let's go ahead and do that. And I'm going to say this is const message element, just like so. And I'm going to give it an ID just to make our lives easier, so we can pick it out later. Temp message. And I'm going to get the message element again and use text content to assign the message that we pass through, and get it again and use style color and make sure that the color of the text is whatever we pass through. So in this case, it's red. And once again, I'm going to use grid append child message element. Okay. So again, I'm going to use set timeout because I want to remove it after a certain amount of time. So set timeout. And this simply means that if there is a message element, parent node, I want to get the message element and remove it. Okay, so it's just safety check really to ensure elements still exist before their removal. Okay. Great. One other thing I do and want to do, and this is just a safety thing, is actually check if any message elements exist. So document get meant by ID, and we're going to search for anything with temp message because we don't want to essentially, you know, show this if one exists already. So const existing message. we want to clear the existing message. So if there is an existing message, then we just want to get that existing message and remove it before showing the new message. Okay, it's just kind of like a safety thing. So that duration now, I'm going to pass through here, okay? And it's going to disappear after that duration. Great. Let's make sure to spell message correctly here. And existing, message seems to have a lot of S's, so let's fix that as well. Great. So that is my show temporary message function, all of that, and we use it in the show enemies remaining message. Okay, let's give this a go. So for example, if I try to open this door, it says, no, defeat all enemies first. Let's style this message. This should disappear after 2000 milliseconds, but we're getting a error on line 254. So like 254 is here. This should be removed, sorry. Okay. So now let's style up this temp message. I'm just going to grab it and all the way down here. So this time it's an ID. And I'm going to position it. So position absolute. Top of the grid, 50%, because this will be in the grid. Remember, we used a pen child grid to put it in the grid. Let's give it a min width as well of 180 pixels. I'm going to also transform it. Translate -50%, -50%. Let's give it some padding, 15 pixels, 25 pixels, border radius, just to soften it by 8 pixels, font weight, bold, make sure that it's in front of things, so Z index 20, pointer, events, none, and then back around. It's going to be RGBA. I want it to be transparent, black with 0.8 opacity. Okay, so now the temp message, let's go ahead. Defeat all enemies first. Okay, so great. I love it. Okay, so this is looking good. We are able to move through walls, so let's carry on working on that and see if you go through a left door and interact with it, it just disappears. So it looks like you can go back through there. That is a useful one for when you want to make more levels. Let's continue. Okay, so back in the move player function, it would seem we could only move the player position. So there we go. If we can move to the player position. So still inside this if statement, we will put that code. Great. So now, ta-da, this is looking good. We cannot interact with certain things. And if we try to go through the door, it says defeat all enemies first, and we get this nice glow around it. This is looking great. Now this means we can move on to making a kaboom to kill enemies. So let's do it. So let's go down here. I'm going to write it here. So function spawn kaboom, and this time we're going to calculate player's current grid coordinates and extract the column and row from linear position for attack placement. So this just means that we're going to get the player position modulus width, and that is going to be let kaboom X, because we want the kaboom to appear in front of the player. So we're going to have to do a few things. We're going to have to figure out what the player is and figure out which square to put it in based on if he's facing left, right, up, or down. Let's also get let kaboom Y, and this time we're going to do math floor and pass through the player position, divide by width. Okay, so now we're going to switch and pass through the player direction And like I said, if he's going left, well then we're going to get kaboom x and attack 1 square to the left. So actually we're going to minus 1 from it. So wherever the player is, or minus 1, because that's where we want kaboom x to appear. And break. And let's do the same for case right. Kaboom x this time is going to be +1. Let's do the same for case up. This time we're going to get kaboom y and -1. And case direction down. This time we're going to add 1. And the y, kaboom y. Okay, so spawn kaboom. That's it for checking where the kaboom will show up. So still inside the function, make sure you're still inside the function. This time I'm going to check if attack position is within the grid game boundaries. So if kaboom x is larger than or equal to 0, and so we've used this logic before, kaboom x is smaller than the width plus kaboom y is larger than or equal to 0 plus kaboom y is smaller than 9. So if all this is true, then yes, you are within the game grid boundaries. And we're going to use document. We're going to create an element. So you know the drill. Let's create a div. Let's assign this to a constant, kaboom element, just like so. Let's get the kaboom element. Just use class name and just override it to be kaboom. Okay, so now once again we're going to get the kaboom element style left and just assign it the kaboom x multiplied by the tile size pixels. Make sure that's all in that. And once again, kaboom style top this time. So let's use the y multiplied by the tile size. And now once again, let's grab the grid, append child, kaboom element. Okay, cool. And what I'm going to do is just this time also I need to remove the explosion, so set time out. And if kaboom element parent node exists, then we get kaboom element parent node remove child kaboom element. Great, and this will happen after 1000 milliseconds. I love it. Okay, so there we go. We can close that up now. One other thing we actually, need to do is check kaboom enemy collision. We'll pass through kaboom x and kaboom y. So we need to actually check if it worked, really. So check kaboom enemy collision. Let's just tidy this up a little bit. Okay, that looks good. So down here, function check kaboom collision. And we're going to loop through all the enemies that we have collected in an array backwards to safely remove items during iteration. So for let I equals enemies length -1, I is larger than or equal to 0. We're going to get I and just go down. So let's get the enemies array, and we're going to pass through I to pick out the enemy that we are working with, and I'm just going to save it as enemy. Then let's get the round enemy positions to the nearest integer for accurate collision detection. So let's get enemy x. I'm going to actually pass it through math round, just like that, and assign it just to enemy x. Okay, so there we go. Then we have enemy y, enemy Y. And if any of these positions, so if enemy X GP equals kaboom X and enemy Y deeply equals kaboom Y, then we remove the enemy's visual element from the game grid. Enemy element parent node, if that exists, we get the enemy parent node and remove child enemy element. So just like that. Okay? Great. So now let's pass through this in here and kaboom Y. So after removing it visually, we also need to remove it from the enemies array. So enemies splice I1, and then we increase the player's score. We update displays, so we update the UI with the latest score. And we break out of this. Okay, so update displays. Now we are yet to write this function. Okay, so maybe let's do that here. Function update displays. We're just going to get the store display that we literally picked out at the very, very beginning. You're going to use inner HTML to just display the score, and then the level display inner HTML to display the level +1, right? Because here we're counting at 0, but to the human eye, we want it to appear as 1. And the enemy display inner HTML, we're going to get the enemies array and just get the length of all the enemies that we've collected in there. Great. So that's really it to update the score. That was an easy function to write. Cool. Once again, this actually needs to happen here. So if both of these equal that, wonderful. So that is my whole check kaboom enemies collision method written already. Wonderful. So great, we're doing that here. We've written the function spawn kaboom, so now we can comment that out basically where we press the space bar. So let's go all the way back here to the bottom and uncomment that out, so we should now be able to spawn kabooms. So it spawns there. That's because we need to do some styling. So here on the kaboom, once again, we need position absolute. Let's add a width of 48 pixels, a height of 48 pixels, a Z index of 15, and then once again, let's just do background size cover, no repeat center. One other thing I'm going to do is just write an animation. There's going to be explode, that's what I'm calling it. 1 second, ease out forwards is what I'm going to do. And now I'm going to get keyframes explode 0% transform scale 0.8 opacity 1, and then at 100% of the animation I want to just transform it to 1.2 and opacity 0. Great. So that is my whole kaboom, and that is my frames, my keyframes. And this just means that if I now press the space bar, ta-da, kind of expands and goes away. I love it. So this is looking good. Let's continue. Let's go back to our app. Okay, so as we are at the bottom of the file, here is the bottom of our whole file. One thing that I would like to do is also write the game over function And we're actually just going to get game running and assign false. And we're going to use the show temporary message function that we wrote previously to just type game over. So we're passing through the string of game over, final score, and then we're going to pass through the actual score. Okay, we're also going to say that we want the text to be white and we want this to last for 3,000 milliseconds. So that's the text that we're going to show. So we'll leave that for now. Okay, so we're showing a temporary message, we're showing enemies remaining, we're updating displays. I think what would be good is we start moving the slicer. So maybe let's do that here. Function move slicer. Let's pass through the slicer. Let's pass through delta time. So this is going to handle slicer enemy movement back and forth. The speed. So const speed. What we're going to do is just going to be 2 multiplied by delta time. You can mess around with this. Okay, I've already kind of done this. This is essentially calculating speed of movement by saying 2 units per second, scaled by delta time for smooth animation. Next, I'm going to calculate the new horizontal position based on current direction. And for this, I've already kind of done this, so there we go. And then I'm going to get the current vertical position as well. Okay, so this is rounded for wall checking. Now we're going to check for boundaries or wall collisions. So again, we've kind of done this logic before, just checking that we're not on 0 or new x is larger than the width. Or then we're going to write a function is wall, because we want to check if there is a wall. I'm going to pass through bar math round, so rounded down, new x and y. Okay, and then we're going to get the slicer direction and just reverse it. So this is a nice way to reverse whatever's there. If it's a -1, it becomes a 1, and if it's a 1, it becomes a -1. Okay, great. Else, we just want to update position if movement is valid. So slicer x equals new x. Now we're just going to update visual position of the slicer element. So you know what to do. We're going to get the element star left and update the slicer x with it. Great. So now let's write the isWall function. So function isWall. I'm going to pass through the x and the y. And this is just a function to check if a grid position contains a wall or a blocking element. So first we're going to convert grid coordinates to array index. So that is how we can do it. And next we're going to check if a position is outside the grid bound. So this is going to return a true if position is smaller than 0 or position is larger than square's length. We return true. Okay, and now let's get the square element at this position. So once again, we go into the squares array to get the current square, and let's just assign it to const square. And you've kind of already done this before. So this time I'm going to check if square contains any blocking elements. So I'm actually just going to copy this from here. Okay, so please go ahead and do the same. Just paste it like so. However, this time we are returning if this is true. Okay, so if it does contain a left wall, or, so let's change all of these to or instead of ands. Okay, there we go. So that is our isWall function. And finally, just like we wrote move slicer, we're going to move Skeletor. So maybe let's do that here. Function move Skeletor. I'm going to pass through Skeletor. I'm going to pass through delta time. I'm going to calculate the movement speed. We're going to go with 1.5 units per second, which is slower than the slicer. We're going to decrease the direction change timer. So we're going to randomly move Skeletor. So if Skeletor timer is suddenly smaller than or equal to 0, I'm simply going to get the Skeletor direction and multiply by -1. So you know that that will change it to a 1 if it's a -1 and a -1 if it's a 1. And we're going to get the Skeletor timer and just reset it. So we're going to do math random, call it multiplied by 5. Okay, and now let's essentially calculate the new vertical position based on current direction. So we're going to do that by getting Skeletor y plus the Skeletor direction multiplied by the speed, and that's the new direction that we are going in. And we're going to get the current horizontal position too. So we're just going to get Skeletor x, pass it through math round, and assign it to the const x. Once again, just like we did with the slicer, we need to check for boundary or wall collision. So if new y is smaller than 0, or new y is larger than or equal to 9, or is wall, and we pass through x, and this time math round new y, then we get Skeletor. Just gonna copy that to save myself writing Skeletor direction and change it, else Skeletor y is just the new y. So we update the position if movement is valid. And we have to visually update Skeletor on our game boards. Great. Okay, so that is all looking good to me. Correct this to be round. Okay, correct that from here to be round. Okay, so we are nearly done. I'm just going to write one function to bring that all together. So above both of these, this is the main function that will move the enemy position based on elapsed time. So move enemies delta time and for const enemy of enemies if enemy type equals slicer. Remember we added that to the enemy object. Then we're going to get the move slicer function, pass through the enemy and the delta time. Else if, I guess, enemy type equals Skeletor, we move Skeletor and pass through enemy and delta time. Okay, so that is our move enemies function. Great. So now we have to put this in a game loop. So all the way down here, all the way at the bottom, let's do above the game over function game loop. Let's pass through the current time. So this is going to be called every frame by the browser. We're going to get delta time, and delta time is simply the current time minus the last time divided by 1000. So this is calculating the time elapsed since last frame in seconds. And then we're going to update the last time to be from the current time. So current time is now the last time. I'm going to set let last time here to be 0. And I'm also going to save the animation ID here. So that's going to be the ID of the current animation frame request. Okay. So now if the game is running and delta time is smaller than 0.1, I'm going to move enemies and pass through delta time. I'm also going to check player enemy collision. We have not written this yet, but that is something I'm going to do. So now that game loop is defined, I'm going to schedule the next frame. So I'm going to grab the animation ID, request animation, and pass through the game loop. Okay, animation frame. So that is looking good. And we're also going to initialize the game here. So I'm actually just going to copy this down here. So this is outside that function. This should actually be inside this function still. So that is in the game loop function. So let's write this function as well. So let's just go back up here, function, check player enemy collision. So this is to check if the player collides with the enemies. That is something that we are going to write. Great. Now we are referring to the Skeletor element and the slicer element here. However, if you remember when we created the elements, so let's go all the way back here, we pass it through as the Skeletor element. I think it's easier for us to just pass it through perhaps as the element Skeletor element, so we can access it for both enemies. So that is for Skeletor, and for the slicer, again, let's just pass it through as an element, just like so. Okay, and great. So now I'm just going to comment out the check player enemy collision in our game loop. And if I kill one, amazing. So we are killing the enemies. As you can see, enemies went down to 0, score went up to 2. I've killed all the enemies, and now I can progress to the next level. So that is something that we're going to have to work on, but I love it. This is looking good. When we go to the next level as well, we should do some clearing of things. So let's go back to the create board function all the way up here. So here is create board, and I'm just going to reset. So reset game running to be true. I'm going to get the grid inner HTML and just put an empty string. I'm going to get squares length and just do 0, and enemies I will clear again because we're going to start from scratch. So this just means that if I now, let's kill the enemies, can't die yet, so that is good. Okay, that is looking so much better. I love it. So one last thing to do, and that is check for a collision with an enemy. Let's go. So all the way back down here. Yes, I commented it out. I'm going to uncomment that. Let's write this function, which we kind of started doing already here. So let's uncomment that out. And this time we're going to calculate the player's current grid coordinates. So let's get the player x's by getting the player position modulus width. Let's also get the player y by getting the player position divided by the width, pass through math floor. So for example, if the player position is 84, 84 modulus width gives us a remainder of 4, meaning that player is in column 4. And for this, if 84 divided by 10 rounded down gives us 8, which means that player is in row 8. For const enemy of enemies, we're going to do the same. We're going to round enemy positions for accurate collision detection. So we get the enemy X and Y. And if, so still in the loop, if enemy X deeply equals player X, and if enemy Y deeply equals Y, it means that the enemy and the player are in the exact same position. And then we can trigger a game over, okay? And then let's return out of this. So that is the whole function, really. It was quite a simple one in comparison to some of the others. Just remove that, and let's test it out. So now, I die. We get a game over. I can't move at all. Okay, we should probably remove that scrolling as well. But this is looking good. Okay, I'm happy with this. So we've done it. I think we have finished the game, really. This is looking so, so good. Let's kill this one too. Bam, 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 bam. I love it. And then we keep going and going. Okay, great. Let's do some tidying up next. So one thing that I do want to do is just get the create board function, just remove the console logs, put the create board function all the way at the bottom. This is kind of to initialize the game. Get rid of any extra spacing that we did. So just like that. Okay. And I think I'm happy with this. Okay, so one thing I've noticed that in the move player function, we should also probably call the check player enemy collision here as well. So I'm just going to add that there. Also in my create board function, I'm just going to update displays there too. So when we create player, we update the displays here as well. In my show enemies remaining function, I wrote filter wrong for some reason. So let's change that filter. I'm just going to change this here to be bigger than or equal to. So larger or equal to. And that should be it. One last thing I'm going to do is just do overflow hidden to stop any pesky scroll bars from showing up. Okay, so that's it. I hope you've enjoyed coding along with me. I thought this was super, super fun. I love this game of Mario, and I really feel like it has the potential to be an incredible game. Please take it, make your own. I'd love to see what you make with this. So please do share it with me, at me, on Twitter, Instagram. I would love to see. Okay, so I hope you enjoyed, and I'll see you again soon.